So hello, everyone. Hope you're doing good and welcome back to my channel. Today we are at day 11 of the April Daily Leetcode Challenge, and we have again a medium level question in front of us. It's again totally different compared to the yesterday's question, but let's see what the question is. It's question 1035, crossed lines. Okay, so yeah, let me tell you till now what we have seen in the May series. So the last two questions were totally on metrics, okay, how we do the simulation and how generate a simulation using code. But today we have a very different question. It looks very different, but once you realize what it is, you will see that it's a familiar question, right? So let's go through what the question is. We are given two numbers array, okay? We are given two arrays of numbers, and we're asked something. Let's see what it is, okay? We are given two integer arrays nums1 and nums2. We write the integers of nums1 and nums2 in the order they are given in two separate horizontal lines. Okay, as you can see here, this is nums1 array 142 and 124. Okay, we write them on separate lines, separate horizontal lines, one of the other. Okay, we may draw connecting lines, a straight line connecting two numbers. Okay, one number connecting from nums1 to another number to nums2, such that both numbers should be equal. For example, you can see if I am connecting two numbers, okay, then they should be equal. Okay, one end should lie on the nums1 array and the other one should lie on the nums2 array. Okay, that is the basic idea, and they should be equal. Line we draw does not intersect any other connecting horizontal lines. What that means is, see, once I've connected 4 and 4, I cannot connect 2 and 2, okay, because then it will be intersect coming, okay, there will be intersection coming. That is not allowed here. That is the meaning of this line, okay. The line we draw does not intersect any other connecting or horizontal lines. Okay, that is the basic idea here. See, once I've connected 4 and 4, I should not connect 2 and 2 again because it will be intersecting them. So, other way you can think of it is once I've connected 2 and 2, I should not connect 4 and 4. Okay, that is the idea. Now, let us see what the question is. Yeah, they are asking the maximum of connecting lines we can draw in this row. The one condition they've given is that note that a connecting line cannot intersect even at the endpoints. What they mean to say is each number can only belong to one connecting line. Okay, each number. See what it means is, see, suppose 4 is getting connected to 4. Then suppose here is 2 is also 4. Then I cannot connect the same. Okay, one number of nums1 is reserved for one number of nums2 if the two are equal. Okay, that is the basic idea here. So yeah, let us trace the example one first of all. See 142 and 124. You can clearly see from this example itself we are getting the idea that the safest option possible here is to always start from one end. Okay, either it could be the start or it could be the end. Okay, we have to start from one end. See, for example, if the last two elements or the first two elements are matching, okay, that is the most safest option possible because it will never ever intersect or come in between. Like, see, it should not come in path of other lines. Okay, that is the basic idea. See, for example, this 4 is coming in path of these two to connect. Okay, so it's obstructing them. Okay, we have to maximize the number, right? That's what the question is, the maximum number of connecting lines. Okay, so the most safest way to do it is to start from either ends. Okay, either the start or the other end. Okay, that is the safest option. If we connect the last two elements, if they match, then that is the best option possible. We can just ignore them after that once they match, and we can focus on the rest of the day. Because see, as I told, see, here it's clearly mentioned. Okay, we cannot. Okay, yeah, each number can only belong to one connecting line. Once this one is used, it should not be used again. So you can just remove them from the array, or you can totally ignore them for the rest of the calculation. That is the basic idea here. In this question, you can clearly see the answer is going to be 2. Okay, because we cannot have more than two connecting lines. See that you have to satisfy this condition, right? For example, if you draw a line between two and it will be obstructing the 4. Okay, so we are ignoring it. So yeah, that was all. Now let us try to build a logic for this. Okay. See, what I will do is I will start from the last. Okay, I will start from the last. What I will do is first I will check if the last element of nums1 matches with the last element of nums2. Okay, if they match, that is the best case possible. You can just leave these two elements out of the array. You can just remove them or whatever you want you can do, but you should not consider them for the rest of the calculation. Okay. For example, if this matches, I can just ignore these two and focus on the rest. Okay, that is the basic idea. So that is what we are doing. Just see, if my nums1 of I is the last possible index, okay, is equal to nums2 of j is the last possible index of nums2, then what we are performing is we are adding one to the answer. What is the answer? See, we are adding one and we are going to solve the from 0 to I minus 1 and 0 to j minus 1. Okay, that is the basic idea. This is like a recursion I am doing. See, solve of I comma j is this. Okay, I am checking if that two are equal. If that two are equal, what I am doing, I will add one and start recursion for the index below it. Okay, I'll start recursion for the index below it. Okay, this is for the case where they're matching. Now suppose like this a case comes, see, here 2 is there, here 4 is there, they are not matching. What we can do in that, see, there are two options possible. Okay, see, just imagine here in this case 2 is here, 4 is here. Okay, they are not matching. What I can do is either I can remove a 2 here, then they are starting to match. Otherwise, what I can do is I can remove this 4 here, and then the 2s are starting to match. So what we have to do is we have to remove at least one. See, either from either of them, I have to remove an element. But how to know which one is more sufficient way? See, because I am not seeing the other numbers of the array, right? I cannot predict which one will be giving me the maximum number. Okay, so what I am doing here is, see, if they don't, see, this is the condition. If they match, if the last element match, see, we are going to start from last. Please make this point very clear. You could have also done it from the start. Okay, but in my case, I'm going to do it from the last. And if they are matching, this is how it is. Okay, I will like add one to my answer, and what, see, add one and solve the elements below it, that is the elements left of it. Okay, so 0 to I minus 1, 0 to j minus 1, because we already solved for I. Okay, ignore I and j now, just solve the elements 0 to I minus 1 and 0 to j minus 1. Okay, that is the basic idea. Now comes the case where they are not matching. So what we're doing, see, we are going to see, I have removed the jth element from here. Now I'm going to consider the array from 0 to j minus 1, but for the nums1 array, it's full. Okay, I have not removed anything. This is the first case. Okay, see, I am taking both the cases. Other cases, I am going to remove element from the nums1 array, and I have not removed anything from the nums2 array. Okay, I will be taking the max of this. Okay, see, I please try to understand these points here. If I'm going fast, you can also pause the video and just rewind it and see. Okay, see, if they are not matching, if the last elements are not matching, we are left. See, I'm going to solve this question through recursion. Okay, this is recursion, and this is how the logic works. Okay, if the last elements are not matching, I have to remove one element from any one of the two arrays. Okay, for example, if I remove 2 here, they are matching. Similarly, if I remove 4 here, they are matching. Okay, that is the idea. I have to keep on removing one of the elements from any one of the array, but I don't know which is the best case possible. Okay, so for because we don't know now in future what will happen. Maybe like elements start matching here or here. So which is the best way to remove? That's why I'm taking the match. Okay, I don't know what's there in the future or what's there in the left of that. Okay, so we are taking the max of it. Okay, this is the case where we are removing element from nums2, and this is the case where we are removing the last element from nums1. Okay, I don't know which one will be the best one, so I'm going to take the max of them. Okay, that is the basic idea. So what we're doing, if the nums matches, I am adding one to my answer and solving the, like, removing the both the ends. Okay, removing one element from the last of both the numbers, nums1 and nums array, and finally I am solving them again. Okay, that is the first case. Second case, if they're not matching, I will check which one is the best case, like from where I can remove one of them. Okay, that is the basic idea. And now do one thing: just see these conditions and just try to think of where you have seen them. Okay, and the answer is, we have seen the exact same conditions in case of longest common subsequence. Okay, this is a very famous algorithm, LCS algorithm, longest common subsequence. If you are not aware of this, you can please search it in Wikipedia. And there are also like few questions, I think, in the uh, April daily Leetcode challenge. There were questions where we have used this algorithm. If possible, I will give the name of the video in the description. You can just go and check that video out. But this is a very famous algorithm, and it's a slightly simple one as well. You can just like read about it in Google and Wikipedia, right? That will be the easiest way possible for you. And you can also see videos on that. But see, for doing this question, you are supposed to know this algorithm. If you know this algorithm, then only it will be a medium level question for you. Otherwise, it will be a hard level question for you, right? So these are exactly the same conditions for the lowest common subsequence algorithm. But even if you don't know this, based on this condition, you can design the answer. But only thing is, like, what dimensions array we are taking, how we are matching these things, you will slightly struggle. Okay. So what I'm doing is, N1 is the length of the nums1 array, L2 is the length of the nums2 array. What we are doing is, we are going to see, I will just print and show you first. See both. See, for example, for num2 and num1, I will take one extra. Okay, one dimension extra. Why I'm doing that, you will get to know soon. For example, I am planning to take for the, see, and the horizontal, see, box. See, if you imagine a matrix, there are two dimensions, right? Okay, yeah, there are two dimensions: the horizontal dimension and vertical dimension to any of the matrix. Okay, so the horizontal dimension will refer to the nums2 array. Okay, and similarly, the vertical direction will refer to the nums1 array. Okay, you see the second case here. Okay, here it is 5. Okay, and here it is 6. So as I said, nums2 refers to horizontal direction. So you can see each of the subarrays has 6 elements. Similarly, if you see how many subarrays are present, there are going to be 5. Okay, you can just count them out. Okay, 1, 2, 3, 4, and 5. They are 5. Okay, and in each of the cases, we are going to take one extra. Okay, so in that case, in this case, see. there are 5 elements present here, so the vertical line will be 6. Okay. Similarly, there are 6 elements present here, so the horizontal line will be 7. See, 1, 2, 3, 4, 5, 6, 7. Okay, here it is 7. And if you calculate how many such subarrays are present, it's going to be 1 plus the length of this, which is going to be 6. That is the idea. Okay. Why I'm taking one extra, you will get to know while see. The idea here is, see, come to this case. Okay, come to this case. What we're doing is, see, we are going to suppose there is only one element in the array. What I am doing, I am going to take 1 minus 1 of that. So index 1, index before that, and 1 index before next here. So there is only one element in the array. Okay. So how it will work? So I need to have some buffer here. Okay. So what I am doing is, see, I am mentioning this with 0. The idea here is, if you see this, the first row and the first column, okay, it will be always 0 even after the, okay, I will just run and show you. This thing will be very, see, these are implementation details. These things you will understand only when you trace the algorithm, right? See, first row and first column will be always 0. Okay, even see, this is the matrix before calculation begins. This is the matrix after the calculation happens. How the calculation happens, we discuss that. But just try to understand the first row and the first column. See, this is the first column. Okay, this this, yeah, and like all the first elements here, these depend on the first column. See, all of them will be always 0. They are acting as a buffer. Okay, why we need a buffer? Because see, we will be referring the always the j minus 1th element. Okay, if j itself is like the first element, what will happen? Okay, there will be errors coming, right? Because we are exceeding the limit. Okay, so to avoid that only, we are taking a buffer here. Okay, I minus 1, j minus 1. See, okay, if I is the horizontal line, then we need a buffer along the column, and similarly if j is the row, we need a buffer along the vertical axis or along the column, right? That is the basic idea. That's why I'm taking always the extra one, whatever experimental noise for this extra one. Okay, yeah. So that was all why we are taking like that. And now the algorithm starts. See, it's a very simple algorithm. We are going to because I said no, first row and first column will be 0. That's why I'm starting with 1 here. Okay, I'm both the ways I'm starting with 1. So let me make it very clear. The horizontal range represents the nums2 array and the vertical one represents the nums1 array. Okay, imagine they are placed there, and then let us solve the algorithm. But see, because I'm starting with 1, see, here I'm starting with 1, right? But we have to match from the first element itself. So this is how I'm doing to ensure that first elements are matched. So 1 minus 1 is 0, right? That's how they're ensured that each element is matched. Okay, see, I'm starting with 1, but I should be matching from 0 to index. That's why I'm doing minus 1 here, right? If I am checking if the first, you can check either the first or the last. This is your choice, right? If we are checking the first element matches, see, you can go for either end. Okay, you can go for either end. That's the most safest option possible. Okay, if they matches, what I am doing, I am doing a calculation for the. You can also call it recursive call, but I am not addressing this in a recursive way. I am doing in an iterative way, right? You can also make a recursive call like it's shown here. But I am in this case, see, this is not calculated at present. Okay, this will be slowly calculated, right? So I'm just adding 1 and doing the calculation further for the I minus 1 and j minus 1. Okay, that means I'm totally ignoring the last element now, and I'm only focusing on 0 to I minus 1 elements and 0 to j minus 1 elements. Okay, this is the case when they're equal. If they're not equal, we know that we have to remove one element from either the first nums one or the second array, which is nums2. Okay, so I'm taking both the case. This is the case where I removed the element from the nums2 array, and this is the case I have removed the last element from the nums1 array. Okay, and then I am matching. Then I am taking the max of it. Okay, which is the max? I'm that taking that. So this loop will continue. As you can see, there are two for loops here. We are going to each of the element. By now, you would have guessed the time complexity is going to be O of n1 and n2, because yeah, they are these are the limits, right? N1 and n2. We are using a matrix, so again space complete is going to be the same. Okay, time and space complete is the same in this case, O of n1 and n2. And finally, we are returning the last element along the, see, last one of the last row. Okay, if I show you in the diagram, yeah, this element. Okay, last element of the last row, that is the always the answer. Okay, if you are thorough with what is longest common subsequence, you will know this. So basically, if you see here, now just see the case. What is the longest common subsequence among them? Okay, it's either 104 or 102, right? So what is the length of that? It's 2. So that is the answer. And that's why I have not raised the example 2 and 3 just to ask you this. Just tell me here what is the longest common subsequence. Okay, we can see 5 is there in both of them, so 5 will be included. Okay, we can see 2 is also present in both of them, so 2 will be included, and we can see 5 is present again. So 5, 2, and 5 is one of the subsequences. Similarly, you can find other subsequences, but we can see that we cannot find anything greater than the length 3. Okay, that is the answer. And coming to this thing, see, 1 is present in the starting itself, always match 1. Then see, again 1 is coming, you can match that. So yeah, we have made two. Similarly, you can try to find other subsequences. Obviously, if five is also there, five you can match. But see, at a time you can see once you have matched one. See, one is here, right? Once you have done one, you cannot match five. Okay, that is the basic idea. Either you can take five or you can take one. You can do any one of them. Okay, so you cannot find any subsequence which is of length greater than two. So the answer here will be two. You can see the constraints here. This is suitable for a O of n square approach, and that's why we have coded that. So ultimately, the idea of solving this question is we have to treat this as like a character error, whichever way you call it, and we have to apply the longest common subsequence. Okay, the longest common subsequence will ensure that the lines drawn do not intersect each other. Okay, that is the basic idea of this question. You can see what I've done is I've done an iterative solution, like iterative approach. You can also do it in a recursive way, but remember, if you are using a recursive way, you have to ensure that you are not recalculating what is already calculated. You have to cache your answers so that the like subproblems are not repeated. Okay, the calculations for subproblems are not repeated. That is the basic idea. That means you have to use recursion with memoization. That is what I'm going to say. In this case, it's already memoized. Okay, the approach here is like, see, this is the finished algorithm. Okay, so it's a totally polished algorithm. You can just go and search it in the Wikipedia. You will get similar examples. Okay, so what I've quoted is like a well prepared algorithm, right? I'm just using it here. That is the basic idea. So yeah, friends, that was all for today. If you have any other ways of solving this, please do comment below. But remember, this what I have shown the idea, that is the main solution of it. There may be some shortcuts, but yeah, this is what we expect in interview. Like they will give you hints, like treat it as strings array, and then think of longest common subsequence. They will just give you the hints. You will have to come up with a code. That is the basic idea. This is really a nice question, and you can think of this how the interview will be going on if such a question asked. Okay, you have to prepare accordingly. Yeah, friend, that was all for today. See you in the next video. Thanks a lot.